That's what you are going to have. Then if you open this, you have 25x minus 5. Open this, we have minus 3 plus 6x. Then this becomes less than or equals to 15 times 8. 15 times 8 will definitely give us 120. So we have 120 plus 15x. So try to collect like terms. 25x is here, plus 6x is here. Then we transfer this one, that is minus 15x, less than or equals to 120. We transfer this one to this side, plus 5. Then this one again, plus 3. So here, 15 and 25x minus 6x, that gives us 19x. 19x minus this, that gives us 4x, less than or equals to, this one becomes 128. Then 120, we divide both sides by 4. Divide both sides by 4. We are going to have 4 here 1, 4 in 12, 3, 4 in this 2, so that's 32. So represent this on the number line, we have, let's say this is your 0 region and this is your 32 region. And since it's less than, it will be shaded, less than or equals to, it will be shaded, and it will come towards the side. So you have something like this. That's the graph of the second one. Then the third case, which is C part. We also look for the LCM. You can express this one as a fraction this way to make it easier for us. Then we have LCM will definitely be 3. So we multiply 10 by the LCM. 3 times 2 over 3 minus 3 into 3x. That's equals to 3 times 2 into 1 minus x. So that is the first thing we have to do. So 3 here 1, 3 here 1. So this one becomes 2 minus 9x, that is equals to, and this one becomes 6 into 1 minus x. So that's 2 minus 9x, less than or equals to 6 minus 6x. So we collect like terms. Minus 9x, we bring this one, that becomes plus 6x, less than or equals to 6, then this one comes closer to minus 2. So we have minus 3x, and we have less than or equals to 4. Okay, so since our interest is to look for our x, we divide through by minus 3. We divide this by minus 3, it will change the inequality sign. It will now face this way. Then we have 4 divided by minus 3. So this one comes to x. Then x will now be greater than or equals to minus 4 over 3. So we go to our number line. This is our 0 region, then our minus 4 over 3 will definitely be here. And since you have this line here, automatically it will be shaded. You have it shaded, and it's greater than, so it will face this direction. So those are the respective results for question 1. State the range of values of x in the below representation A, B, and C. That has been shown in the previous calculation, where A, B, C graphs are given, and we're able to use the graph to determine the range of values of x. In question 3, what is the range of values of x for which 3 into 1 minus x is greater than 3, and 3 into 1 plus x is greater than or equals to 0. Here we are given two inequalities. So here the first one, 3 into 1 minus x greater than 3. We open this, 3 minus 3x is greater than 3. So here we collect like terms. So we have minus 3x greater than 3 minus 3. So minus 3x is definitely going to be greater than 0. So we divide both sides by minus 3. So the inequality sign will definitely change. So this one becomes, this one will definitely be 0 now. So x is less than 0. So that's the first case. Then the second case, you have 3 into 1 plus x greater than or equals to 0. Open this, we have 3 plus 3x greater than or equals to 0. So 3x is greater than or equals to 0 by collecting like terms. So you have a 3x is greater than or equals to minus 3. Dividing both sides by 3, we have 3x divided by 3 greater than or equals to minus 3 divided by 3. So this one cancels out, and we have x is greater than or equals to minus 1. So x is less than 0 here, and this one x is greater than or equals to minus 1. And since the question asks us to determine the range of values for x for which these are both satisfied, so automatically we are going to have x is less than 0 and x is greater than or equals to minus 1. So here we have a kind of graph where this is your 0 and it's not shaded. So this x less than 0. And we have another graph, this one is shaded. We have another graph, this one is shaded, but this one is minus 1. So 0 is here, so minus 1 will definitely be here. So that means you have it being joined at this point, and it's this. So automatically we can write that since x is less than greater than or equals to 0, we can write our x to be rather our minus 1 can definitely be less than or equals to x. And since our minus 1 is less than or equals to x, so then we have minus 1 less than or equals to x, and then x is less than 0, so less than 0. So this is the solution or the range of value for x in that. Then question 4. Express 3x minus 2. This is a different case now. 3x minus 2 less than 10 plus x, and it's also less than 2 plus 5x. You have something like this, you have a scenario like this, and we are asked to express in the form of a less than x, x less than b. So what we do first is, you can see that we have 3 terms and 2 inequality sign. So the best way to handle this kind of problem is to take this with this first, and you take this with this second. So you're having 3x minus 2 less than 10 plus x, that is the first one. Then we'll have 10 plus x less than 2 plus 5x, that is the second one. So let's solve them one by one. The first case, we have 3x minus 2 less than 10 plus x. So here we collect like terms here, this one comes here, you have 3x minus x less than 10 plus 2. So this one gives us 2x and this one gives us 12. So divide both sides by 2. Divide both sides by 2, we have our x to be less than 6. That's the first case. So we come here with the second case, then we have 10 plus x less than 2 plus 5x. Then we collect like terms also, then x minus 5x less than 2 minus 10. So this one becomes minus 4x, and this one gives us minus 8. So here, divide both sides by minus 4. By dividing both sides by minus 4, the inequality sign changes to this way, and you have this minus 4. And this one comes to this 2. So our x is greater than 2. So we have a scenario where let's say this is our 0, our 2 is here, and it is greater. It's greater. Then, let's say this thing extends to this region, and we also have our x less than 6. Automatically, let's say our 6 is here. Our x is now less than 6, automatically to form like this. So they are coming together. And since they are coming together, we know that since our x is less than, our x is greater than 2, so definitely our 2 is less than x. And since our x is less than 6, it has to be less than 6. So this is the range or value of x that satisfies this inequality. Linear inequalities in 2 variables. It follows representation on the Cartesian plane such that if
x, y represents any point on the Cartesian plane which has coordinates x and y such that x is equal to 2, then x, y may lie in anywhere in the unshaded region as shown in the figure 1.1. You have a Cartesian plane, Here we have the vertical axis, which is our y-axis, and the horizontal axis, which is our x-axis. This is our y-axis. So this is a typical example of a Cartesian plane where the positive values of x start from this region and moves towards the right hand side, while the negative values of x start from this origin and move towards the left hand side of the Cartesian or the graph. Then the y-axis, the positive moves towards the upper part of the graph, while the negative moves towards the downward part of the graph. So a case whereby, let's see some example where our x is greater than or equal to 2, then when our y is greater than -3. So in this two scenario, we sketch our graph such that for the first case, that is x is greater than or equals to 2, then this is our y-axis, this is our x-axis. This is the origin, and since our x is greater than or equal to 2, let's say our x equal to 2 will be the equation